For my design, I decided to make a flashlight. And the first problem you need to ask yourself is, when you are camping, you realize you brought a broken flashlight, and using the materials you have in your bag, you have to create a new device that can create a light source and turn on and off on demand. I imagined different ideas, and the things I came up with were, how can you direct the light? How can you create a switch? And what kind of source can you use to turn on the light? In my initial planning stages, I tested the two lights I had. I had two LEDs, one that was blue and one that was white. And as you can see through the fractal glasses, the white light emits a full spectrum of light, whereas the blue only emits blue and a tiny bit of green. I also tested different kinds of batteries with the LEDs and noticed the AA and AAA did not work as well as a coin cell battery, so that's ultimately what I ended up using. When I was creating, I started by putting aluminum foil on the top of the tube to kind of fit it to there, and I put the light through. I eventually ended up taping tape around the inside of the LED because it touching the tin foil made the current get lost within the tin foil. After, I originally started by using insulated wire, and I ended up changing it from the insulated wire when I realized I kept losing the connection between it. It kept slipping off. So I changed to using copper wire because it had a sticky end that would easily stick inside of my tube, as you can see right in this picture. In the end, you can see I created a switch by cutting the tube a little bit and creating a flap. The copper wire continues inside this way and inside this way. And you can see going up, I would have this one attaches to the negative and this one attaches to the positive. So I would put the positive side of the battery over here and the negative side over here. And when you flip the switch down, the light turned on. I used the TI sensor to help gather some light intensity data. Before the light was shining on it at all, it had 3.1 lux. When it was 30 centimeters away, it had 543.5 lux, and when it was 5 centimeters away from the sensor, it had 2,595.2 lux. And from that data I created a graph to help show it. To improve this, you guys saw I started with insulated wires and I moved to a copper wire strip. I started taping the LED because I noticed that the electric current got lost. And finally, if I were to do it again and had more materials, I would have liked to use a soldering gun to solder the insulated wires to the actual LED because it would have made a stronger connection than either of them. For my STEM lesson design, as you can see, I had to break it up into several different pages. I'm not going to read everything, but I wanted to point out a couple of them. The only area that did not receive a 2 on my checklist was, will students relate to the problem? I said that some students may relate to the problem, but many will have never had to have made a flashlight. By incorporating the situation where they're being stuck camping with no flashlight, it would assist students in relating more with the topic as a whole. As you can see, everything else ended up with a 2. So my final remarks, the TI sensor was useful for collecting actual data about the effectiveness of the flashlight. The STEM lesson design was a 21 out of 22, and varying the materials will help promote creativity in the students. Thank you, everybody.